First, let's introduce first moment of inertia. There are two definitions of first moment of inertia. One is for x-axis and another one is for y-axis. Consider an arbitrary region with center of geometry located here, and then we draw the x-axis and the y-axis on this shape. So what is the first moment of inertia about the x-axis? So about the x-axis, it is given by the summation. So bear in mind that integral is a kind of summation. It is the summation of the altitude of differential area element. So imagine we have a differential area element located at position y. Then the first moment of inertia generated by this differential area is given by y dA. And we are interested to the first moment of inertia of the whole piece of area. Therefore, we will do the integration or the summation. So we integrate all those things over the entire area. This is why you can have this notation. Similarly, for arbitrary shape, geometric center, you have x-axis and the y-axis. For the differential area dA, it is located at position x. So let's see, this is x, okay? Then the differential first moment of inertia dq is given by x dA. And consequently, in order to summarize or integrate the entire area, we just take the double integral of it, x dA. This is why you can have such definition. So the first moment of inertia is very useful for evaluating the centroid of a piece of cross-sectional area. But I will not introduce it in this very first video because such concept, such method will be introduced in the later chapters. Now let's consider an area which is initially located here, and we try to transform it vertically upward and horizontally rightward. As you can see, when this area is transformed horizontally rightward, the first moment of inertia are all the same. They are zero. Notice that it is zero because this shape is symmetrical about the x-axis. The axis of symmetry is coincident with the x-axis. Now, if we transform this area upward, then we can see the first moment of inertia increases. Let's try to understand the value of the first moment of inertia by mathematical manner. As you can see, Qx equals to integral of the entire area y dA. So in this case, the average value of y of all differential area elements is y equals to 1. Therefore, you know that the average is 1, then the total of y times the differential area sum or integrated over the entire region is given by average of y times the entire area, which equals to 16. Similarly, for this case, you can see that the average of y of all differential area elements is 2. Therefore, the first moment of inertia is given by the average of y times the entire area, which is 32. For those cases which the area is symmetrical about the x-axis, you can see that the average of y is 0, and we know that the average of y times the area will also be 0 because the average of y is already 0. Therefore, we can see that no matter how we transform the shape from left to right, or similarly from right to left, the moment of inertia, the first moment of inertia, will still be constant, which is 0. The reason is that no matter how we translate the shape, those shape is always symmetrical about the x-axis, as you can see here. Similarly, if we transform this shape, in this case, you know that the first moment of inertia is 16. If you transform it leftward by some units, maybe 3 units, then the first moment of inertia will still be identical, which is 16, because the axis of symmetry, which indicates the average of y, is not changed. It is always 1, no matter how it translates horizontally. Just now we only consider the case of Qx equals to the integral of the entire area y dA. In such case, no matter how the shape is transformed horizontally, the moment of inertia will not be changed. If we explain the first moment of inertia in words, that means it is the sum of position times area. Position, what I mean position here is x or y, and area is the area of the area element dA, and what we just did is to sum up all those xdA or ydA to be the element of the first moment of inertia. Notice that the first moment of inertia can be either positive or negative. So in case the area just now is translated downward, then the average of y will become a negative number, and consequently, the first moment of inertia will become average of y times the entire area, which is less than 0. So bear in mind that first moment of inertia can be positive or negative.